Hello everyone, welcome to Leetcode number 2582, Pass the Pillow. This problem isn't too difficult and I recommend everyone to try it for at least 10 to 15 minutes. It's mainly just testing your intuition and how you think about problems. So yeah, let's just get started. In this problem, there's n number of people standing in a line, and every second, the person with the pillow passes it on to the next person in line. And once you reach the end of the line, the direction switches. Basically, they start parsing backwards in the line. So let's just understand this with an example. So when there's 4 people and 5 seconds, you can think of seconds as basically the number of passes. So let's just look at it. So with the first pass, it goes to the second person, and with the second pass, it goes to the third, and with the third pass, it goes to the fourth. Now remember, there's only 4 people in this line, so now we switch direction. So for the fourth pass, we go back to 3, and for the second pass, we go back to 2. Now, the key insight you have to make here is that it takes exactly 3 passes to reach the end when there's 4 people. And if there were 5 people, it would take exactly 4 passes to reach the end. Now, why does this matter? Because when it reaches the end, the direction switches. And it's also important to note that, say there were 7 passes, right? After it takes 3 passes to reach the end, it'll take another 3 passes to reach the beginning. And remember, there's still 7 passes, right? So now we're going back in the forward direction, and you'll take 1 more pass to complete 7, and you'll reach back to 2. So again, if you have not noticed, the number of passes it takes to reach the end is very, very important. You'll notice 3 repeats here, twice. So the key insight you have to make is that whenever you subtract 3 from the number of passes, you can basically switch the direction. So if there were 5 and you subtract 3, which is just basically the number of passes it takes to reach the end, you can figure out that, again, 5 minus 3, 2. So it's basically 2 passes in the backwards direction, because again, you can't subtract 3 from 2, you'll become negative, and you can't have negative passes. And you can do something similar with 7. If you minus 3, you know there's 4 passes in the backwards direction. If you minus 3 again, you know there's 1 pass in the forward direction. So if you notice, if there's 1 pass, it's basically in the backwards direction. And if there's 2 passes, you know, if there's 2 passes, you know that it's in the forward direction. So now, how can we generalize this? Here, we just chose 3 just because it takes 3 passes to reach the end. But we can intuitively kind of understand that it takes n minus 1, basically 1 less than the number of people. So a key value here would be n minus 1. And again, we're subtracting multiple times. And a better way to do that would be to divide, because again, repeated subtraction is just division. So if we divide by n minus 3, so here n would be 4, 5 divided by 3, that would give us a fraction. We don't really want fractions or fractional decimal values. So if you take floor division, basically just the closest integer value. So for 5 floor division 3, we'll get 1, and if we did this, we'd get 2. So let's just get started with trying to code up the solution. So as we were discussing the problem, we noticed that n minus 1 clearly matters a lot. The time and floor division of this n minus 1 matters for direction. And another thing that matters is obviously the remainder, because let's take the example of either time equals 7, and when we do this operation of floor division, we'll actually end up with a remainder of 1. And using this remainder, we know how many steps to take. Because again, if you go back to the problem, you'll notice that when you subtract 3 twice from 7, you get 1. And with the direction, we can just add that value and find the position. So going back to the problem, clearly the remainder also matters. And there's two main cases to take care of, basically when it's going forwards and when it's going backwards. Let's just start with what we return. So if you're going forwards, all we'd have to do is take the remainder and just add it on, because again, we're just starting from the position 1 when we're going forwards. So the way we do that is we take the remainder of when we divide it by n minus 1, and we'd like to add 1. You might be wondering, why do we add 1? And that's because we start from position number 1. If we did not account for that, you'd get a possible position of 0, which is not possible as an output. And you can just think about it logically if you want. And again, how do you figure it out if it's going forwards? Remember, this is the key value that we care about. So if this value is even, you know that you're in the forward direction. And if it's not even, you know it's going backwards, right? So now how would we think of returning the position for the backwards value? Again, you're going to start at the final position when you're going backwards. So we take n, and we'll obviously want to subtract by the number of passes, and this will be the number of passes. So yeah, you might be surprised, but this is all it takes. This Leetcode problem only takes 4 lines of code. And if you want to be even more efficient, you don't need this else statement, because the program will just stop running and return. So yeah, all it takes is 3 lines. Now the more attentive of you might have noticed that we have a mistake here, and it has to do with this tiny piece of code. And the problem is order of operations. Now we might have intended to use floor division with time and n minus 1, but the computer only looks at this first part, computes this, and then just subtracts 1. So to prevent this bug, all we have to do is just add brackets so that the computer knows the correct order of operations. Now if you run this code, we'll see that it works, and we can submit this code and see the time complexity and space complexity. And it does work. And the thing to notice is it will be O of 1, because no matter how big the n or time is, all that matters is this computation, and that should be only an O of 1 time. And we're not storing anything, so it's also O of 1 space. Anyways, that was Leetcode number 2582. Pass the pillow. Thank you for watching.